Good morning, students. Welcome back to this data structure class, software engineering class again. As you know, we are discussing about software requirement specification activities, that is producing a SRS document. So this software requirement specification is one of the fundamental activities in the software development. The aim of this activity is to produce a document which contains the user needs, what the system is going to provide, proposal system is going to provide, everything is going to be recorded in this document. So what are the three activities in generating that SRS document? Namely, problem analysis, requirement specification, and validation. Currently, we are discussing about problem analysis. Analyzing the given problem, that is, what is the requirements of the customer, what are the things that the proposal system should do. This is called problem analysis. This is done by four methods, namely informal method, DFD method, and object-oriented modeling, and lastly the prototype modeling, which we are going to discuss now in this class. Now, let us elaborate on this prototyping model. This prototyping takes a different approach to problem solving when comparing to other methods. In prototyping, a partial system is constructed first. Then that system is used by the client, other stakeholders, and for that matter, developers also, to gain a better understanding of the problem and the needs of the customer. So the actual experience with your prototyping that implements part of the eventual software system are used to analyze the problem and understand the requirements for the eventual software system, that is the final software system. So a software prototype can be defined as a partial implementation of a system whose purpose is to learn something about the problem being solved or the solution approach. That is the thing. In fact, such a thing we have already introduced some time back in the beginning of the software engineering period classes. Okay. Now, the rationale behind using prototyping for problem understanding and analysis is that the client and the users often find it difficult to visualize how the eventual software system will work in their environment just by reading a specification document. Okay, so just by going through that SRS document, the the client may find it difficult to understand you visualize the final system. Yeah, okay. So visualizing the operation of the software that is yet to be built and whether it will satisfy his needs and objectives just by going through the SRS document is really a difficult task for the client. Okay. The problem is compounded If the system is totally new, that is, there is no manual system is there, and everything has to be started from the scratch and everything. If that is so, and many users and the clients do not have a good idea of their needs, what is their actual needs are. If they don't have anything, then the problem is compounded. So the work will be heavy more. Okay. So the idea behind prototyping is that the clients and the users can access their needs, assess their needs much better if they can see the working of a system, even if the system is a partial system. So just like this, before finishing your constructing a house, if the user is allowed to use that house in a partially completed house, then after spending some days in that house, the user will highlight more and more needs, more and more updates that are required in that house, more and more facilities that has to be introduced, that has to be adapted in that final house. What are the main difficulties are there currently? If he could explain all these things, then the builder can improve the partially constructed house. The same thing is applied here also. So build the partially constructed prototype of the system, allow the user to use it, and get the experience from him and do it, improve it more. That is the idea behind this prototype model. Okay. Now, there are two approaches to prototyping, namely the throwaway model and the evolutionary model. Throwaway approach and evolutionary approach. Okay. In the throwaway approach, the prototype is constructed with the idea that it will be discarded after the analysis is complete, and the final system will be built from the scratch. That is the idea behind the throwaway approach. Whereas in the evolutionary approach, the prototype is built with the idea that it will eventually be converted into the final system. That is the idea behind this evolutionary approach. Okay. Now, whether it is a evolutionary approach or a throwaway approach, first of all, you should ask the question that whether a prototype is needed or not. Okay. That is, in other words, it is important to clearly understand when the prototyping should be done, whether it is prototyping should be done immediately or it can be postponed or not. Okay. The requirements of a system can be divided into three types, namely those that are well understood, and the requirements that are poorly understood, and the requirements that are not at all known. Okay. So in the throwaway prototype model, the poorly understood requirements are the ones that should be incorporated. Okay, first of all. Okay. Now, it might be possible to divide the set of poorly understood requirements further into two sets, namely critical to design and not critical to design. Okay. The requirements that can be easily incorporated in the system later are considered to be non-critical to design. Okay, so such a things can be that are non-critical, that can be added at any time. They are called as non-critical. Okay, so the prototype model will help you when there is when no idea about the proposed system is there. So you build a system based on your previous experience and allow the user to use it and get the feedback from him, refine it, improve it, refine it, improve it, refine it, like this. That is the approach followed in the prototype modeling. Okay. So we have completed the first activity, that is problem analysis activity in SRS document preparation. Okay. The next activity is specification, SRS specification, requirement specification. So to specify our SRS document, SRS, we should know the characteristics of the proposed SRS document. What are the characteristics? My document, SRS document should have all these things. Okay, namely there should be a correctness and a completeness, unambiguous. It should be unambiguous. It should be verifiable. It should be consistent, and it is traceable, and it should be ranked for importance and stability. Now let us see these characteristics one by one. Okay. So when do you say your SRS is correct? An SRS is correct if every requirement included in the SRS represents something required in the final system. Then only it is called as correct. Okay. Once again, I repeat, an SRS is correct if every requirement included in the SRS represents something required in the final system. Then only it is called as correct SRS. Then when do you say call it as a complete SRS? An SRS is complete if everything the software is supposed to do and the responses of the software to all classes of input are specified in the SRS. That is, it is complete if everything the software is supposed to do and the responses of the software to all classes of the input are given in the SRS. Okay, then only you can call it as a complete SRS. Okay, when do you call it as unambiguous? There should not be any confusion. That is unambiguous. An SRS is unambiguous if and only if every requirement stated has one and only interpretation. There should not be more than one interpretation. Then only it is called as unambiguous. Okay. Then verifiable. An SRS is verifiable if and only if every statement requirement is verifiable. If there are 100 statements, means every statement of the 100 statement should be verifiable. Then only you can call it as a verifiable SRS. Okay. Consistent. And SRS is consistent if there is no requirement that conflict with one another. Okay, there should not be any overlapping between the requirements. Okay, and a requirement is asking for something, and another requirement is asking for something opposite, and they are overlapping, means then it is not consistent. So an SRS is consistent if there is no requirement that conflicts with another. Okay, then traceable. Sorry, ranked for importance. Yeah, SRS is ranked for importance or for stability If for each requirement, the importance and the stability of the requirements are indicated. So what is the importance of that particular requirement? If that is so, then it is called as it is ranked for uh, importance and stability. Okay, that is the thing. So SRS should have all these characteristics. Okay. Now, these are the expected characteristics in a software requirement specification document. Okay. Now, coming to the components of a SRS. Okay. If at all you have a, if at all you have SRS documents, what are the components? See, try to understand characteristics is different from components of a SRS. Okay. So the major components of an SRS are there should be a functional requirement in that document. There should be a performance requirements. There should be design constraint requirements. There should be external interfaces requirements. Okay, that is, there should be information for in functional requirements, information for performance requirements, information for design constraint requirements, information for external interface requirements. Now let us see what is this four requirements. Okay, first we take this functional requirements. The functional requirements specify which output should be produced from the given inputs. Okay, for this input, what is that corresponding output? That should be mentioned, specified in the functional requirements. So they describe the relationship between the input and the output of the system. Okay. For each functional requirement, a detailed description of all the input data and their source and their units of measure and the range of valid inputs should be given. Okay, where are they from? What is the range within which the input can be given, and everything should be given. Okay. All the operations to be performed on the input data to obtain the output should be specified. Okay. To get this output, you should perform these operations on this input. Then only you can get this output. Those operations should be specified. Okay. Some operations like validity checking on the input and output data, parameters affected by the operations, and equations or other logical operations that should be used to transform the inputs to outputs. Everything should be given. Okay, so these are the functional requirements information that are required that should be available in a SRS document. Then coming to performance requirements, the performance requirement component of the SRS specify the performance constraints on the software system. Okay, what are the constraints are there for the performance? Okay, all the requirements relating to the performance characteristics of the system that should be clearly specified. Okay, the performance requirements are of two types, namely static and dynamic. Okay, static requirements. What is the static requirements? The static requirements are those that do not impose constraint on the execution characteristics of the system. Okay. So examples are number of terminals to be supported, number of simultaneous users to be supported, and the number of files that the system has to process and their sizes. So roughly saying, you can see the capacity requirements of the system. Those things comes under static requirements. Okay. Now, what is the dynamic requirements? The dynamic requirements specify constraints on the execution behavior of the system. Okay. Some examples like response time and throughput constraints on the system. Okay. What is this response time? This response time is the expected time for completion of an operation under specified circumstances. Okay, that is response time. Throughput is the expected number of operations that can be performed in a unit time. Okay, in the particular unit time, how many operations that you can do, that is called throughput input. Okay. Now, the next component is design constraint components. Design constraints requirements. Okay. See, there are number of factors in the client's environments that may restrict the choices of your designer. Okay, like resource limit, operating environment available there, and security requirements like this. Okay, so our SRS should identify and specify all such constraints available in the client environment. Okay, so some of them are standards compliance, hardware limitations, reliability, and fault tolerance, security. So these are the constraints that should be addressed in the design constraints. Okay. So this standard compliance constraint specifies the requirements for the standards the system must follow. What are the standards the system should follow? That is given here. The hardware limitation is the proposed the final system software may have to operate on some existing system or the predetermined software. Okay, so the final system should work. Okay, what is the hardware that is chosen for implementation? Okay, fault tolerance requirements is a big issue, or it is often make the system more complex and expensive. Okay, there should be some amount of fault tolerance should be there in the proposed system. Okay. See, this security, they are all significant in some very critical applications like defense systems and medical intelligence, medical applications. In those areas, the security concerns are very, very important. Okay, they have to be incorporated in those systems. Okay, and the final one is external interface requirements. Okay, all the interactions of the software with the people, hardware, and other software should be clearly specified. Okay, they are not external issues. Okay, a preliminary user manual should be created with all user comments, screen formats, and an explanation of how the system will appear to the user, and feedback and error messages. Everything should be given in the as a external interface requirements in the SRS document. So these are the four components of an SRS, namely functional requirements, performance requirements, design constraints, and external interfaces requirements. Okay, so more ideas are there for this specification of the SRS document. Possibly in the next class, we will see about the structure of the SRS document. Okay, what is the structure is there, so that the specification may be easy in the SRS document. That we will see in the next class. Okay, see you in the next class.